The software-defined networking and OpenFlow webinar was made possible by the sponsorship of Big Switch Networks. Big Switch Networks are developing an SDN application for network virtualization, and you can get their open source SDN controller called Floodlight at the openflowhub.org. You can find Big Switch at bigswitch.com.
This webinar is just one of many vendor-independent data center and virtualization webinars available on IPSpace. To learn more about them, visit ipspace.net. And don't forget that you get immediate access to all of them with a yearly subscription.
When we talk, perhaps the first thing to talk about is to say, what is a networking device? A networking device really has, in the traditional functional model, has three planes of operation: the management plane, the control plane, and a forwarding plane. And they all define different things. So the management plane is usually referred to as being where the CLI is. And the CLI uses the SSH protocol, the SNMP, and that's how you attach to configure or to maintain the device and to load firmware and things like that. The control plane is the, I'll jump to the forwarding plane. The forwarding plane is where the data goes. The data comes up, comes through the forwarding plane, and then back out again. It's very simple. Packets, frames, come up, received off the input port, they go through a forwarding engine and then dispatched out a second port according to what's in the table. The final plane is the control plane, and that is the area of the software which loads the forwarding information. So what is it? How is the forwarding information set up? And the control plane usually consists of OSPF protocols or BGP or LDP or ISIS, whatever it is that you want to be able to use, or in the case of switching, you would talk about spanning tree or maybe some of the newer protocols, Trill. So that model is very useful because in the next part we'll start to look about how forwarding tables work. Right? So if we talk about a forwarding plane as being a series of forwarding planes where in a network we bring them all together, right? Then what we can actually do is a packet's actually received, passes through the forwarding plane, goes on to the next device, and then goes forward to the next device. And this is the forwarding plane that comes through the network. So each forwarding plane in each device today is standalone. So that is, the frame comes up off the interface, hits the forwarding engine inside of the switch or the router, and then it selects an output port, and the packet or the frame is then dispatched. And the next device does the same thing, decides whether to send it one way or the other. Inside of each device, then, the forwarding is determined by a forwarding table. Now, linguistically, forwarding tables are literally this destination address is out that port. Now, whether that's a frame relay port or an Ethernet port or it's an IP, whatever, it doesn't really matter. A forwarding table is a very simple out, match this address, send it out that port, or even match this interface, send it out that port. Forwarding tables is the same thing as a forwarding information base. Because the word base is an extrapolation from the word database, so forwarding information database, or a FIB for short. So you may hear me use any one of those three. Apologies in advance. But how routing becomes forwarding is really important. In a networking device, we often talk about a thing called a RIB, and your routing protocols are what we use to gather information together from all of the devices in the network. And those RIBs, like OSPF or BGP, provide information which is then loaded from the RIB, and the RIB selects the best route that are from all the routing protocols. So a router that has an OSPF says, here's a network. That means that any IP packet that is destined to this IP address and then selects the best one of those. The RIB is the one that says, here's the best data. That best route is then loaded into the forwarding table. And that's how routing becomes forwarding. So now we have data coming through the forwarding plane, hits the forwarding information base. The RIB loads, which is in the control plane, loads into the FIB. Right? Okay. So our routing protocols, which I've referred to, are what loads the data into the RIB. So OSPF, BGP, talks to its neighbors, gets information updates from there, loads that down into the RIB, loads that down into the FIB. Packet is received, a lookup in the FIB is done, and the packet is dispatched forward. That, in a modern network, is routing and how it works through the entirety of our system. Now, that is pretty straightforward. Most people would be familiar with that.